Hello, all. Um, we thank God for this opportunity to go through this lecture. Let's have a short prayer as we start. Heavenly Father, we thank you this day once again for helping us to come this far. As we go through this lecture, may you lead us through. In Jesus' name, I pray. Amen. Thank you. We are going to look at the topic on sectional views. Sectional views. And we'll talk about sectional views, which may also be called sessions. They are mainly used to show interior details of objects. Some details of the object which are too complicated to be shown using the traditional lithographic views method. Okay, we understand that photographic projections, when you're looking at photographic projections, some of the details which may not be seen from the outside of the object are indicated with hidden lines. So when you observe an object, the features of the object which you cannot see from the direction at which you're observing the object, you indicate them with short dashes to show that these are features of the object existence but cannot be seen from the direction that is being looked at. Okay, and when we have complicated shapes, you may not be able to clearly see these features of that object. You may not be able to dimension the features properly. So what you do is to provide an imaginary sectioning or cutting through the object to reveal those internal features of the object. All right, and let's look at this figure here. So in this figure, we can imagine. Let's imagine that you have some part that you are cutting through. So let's take this three-dimensional object here. We are cutting through it, and the saw that we use to cut through will go through a certain section of this object. So that plane described by the saw is what we call the cutting plane. Okay, so let's take, for instance, you bought a bread and you want to cut it into two. You use that bread knife and then you cut through, you section through. When you cut through and you open it, you are able to see the features of that bread within it. Okay, basically that is what we are doing here. So here we are just cutting through the object and revealing the features. So if you take this object, for instance, you will see that we have some holes in here. There is some countersink hole here. All right, so some here, and if you look at the other side too, we have some there. But when you look at it in 3D, you are not able to see these features clearly. If you are to draw the orthographic projection of this object, say from this direction, you are going to have representation of these holes drawn, but use hidden lines to draw them, short dashes to indicate that these features are there. But when you section through them, then those features are revealed. Now you can clearly see that this is how the features look like. Okay, so the act of cutting through this object to reveal the internal features of it is what we call sectioning. So again, let's look at that object up there, figure 2.1, in the photographic projection form. That is a plan of it. In the plan, we are seeing these holes at this point and then that point there. Then when you look at the front view, this is how it will appear. If we are to draw the front view of this in the photographic projection, we are going to have the outline of these features to be presented in short dashes. All right, so it will be presented in short dashes to indicate that these features are there. But the moment we section through it, we have revealed the features. So we use continuous thick line to indicate the outline of the features inside. And Cutting plane is what we use in opening or cutting the object into two. And the cutting plane line, if you look at this one here, that is how we indicate them. We indicate the cutting plane line. So cutting plane, basically here, we have the cutting plane itself, and then we have the arrow at the ends, which indicate the direction at which the object is to be observed. Okay, so here when you cut through this object through the middle section using the cutting plane AA, cutting plane AA have gone through the object through the middle section that way, and it has revealed these two features. So it has revealed these two features here, this one here and that one here, and we want to observe it in the direction of this arrow here, A and A. So viewing this direction, the feature we are going to see is this one. So basically we cut through this object and then we throw away the bottom section, and we're observing the surface, the cut surface of the top one, and the outline that will appear will be like this one. So we're looking at the representation of the cutting plane. Section views show how an object would look if a cutting plane or saw cut through the object and the material in front of the cutting plane was discarded. Okay, so here let's look at this one. We cut through this object. When we cut through, we discard the front part. How will the other one look like? That is this one. So the cutting plane which goes through this plane is basically that imaginary plane that goes through the object, okay, to cut it into two. All right, so that the features of that object, the inner features, are revealed. A cutting plane line indicates where the imaginary cutting takes place. The position of the cutting plane is indicated, when necessary, on a view of the object or assembly by a cutting plane line. So that cutting plane line is what we have here. So there are different types. It could be like this. So basically you have this line here, right? It's a chain line. Then we have arrows at the end. So the arrows indicate the direction at which we are looking at the object. And this is another one. And again, we have the arrow at the ends pointing to the direction at which the object should look like. So any material of the object below this line will be discarded, and then we focus on what is in front of the cutting plane. Assuming the arrows are pointing downwards, it means that we are going to discard whatever is above the cutting plane, looking at what is there downwards, and observe the face of the um, sectioned surface. All right. Now let's look at the section lining. Section lining indicates the surface that has been cut and makes it stand out clearly. So basically, when you cut through the object, let's go back and look at this one. When we cut through this object, we realize that we have some void within the material. Some area where there's no material there is open, or this slot which has gone through this material. When we cut open, you realize that this knife we have used to cut the saw or the cutting plane will go through no material in the space where there is void. Okay, there's no material there, but the area where there is material, where the saw have gone through, we need to hatch or provide these hatch lines, okay, to indicate that these are the areas where the cutting plane have gone through some material of the object we are sectioning or cutting through. And that's what we call the section lining or the hatch lines. Section lining usually consists of thin parallel lines drawn at an angle of approximately 45 degrees to the principal edges or axis of the part. So you look at the principal edges or axis of the part, and then you draw lines inclined at an angle of 45 degrees approximately. All right, it may not be the same throughout, but approximately 45. And you have to ensure that this section lining or the hatch lines are equally spaced. Okay, the intervals between them as close together, I mean they are as equal as possible as we section through. So if we take this figure for instance, the section lining is this inclined lines that we can see here, and around the inclined line we have the boundary. Okay, this is the edge, and within this object there is a void. So you see that the section line from this edge to this line here, from this line to this line, and it goes around it, and you are clearly able to see the area where there is no material or where there is a void. All right, and where there's material, where the cutting plane have gone through, is also revealed. um, because the exact material specification for a part are usually given elsewhere, the general um, use section lining is recommended for general use. Okay, yeah, so the general use section lining is the 45-degree solid parallel lines. That's what is basically recommended in all cases. When it is desirable to indicate differences in materials, other symbolic section linings are used, such as those shown in this figure here, figure 2.6. So here, based on the material, assuming you want to differentiate between different type of materials, maybe there is a particular system that have been built, and it's made of different parts, and the parts of different material, and you want to differentiate between the various material in your session, then you have to go according to these symbols that we have here. So if it is the material is a cast iron, then your section lining should look like this. If it's a steel, it should look like this. Bronze, brass, copper, and other compositions, you should have it drawn this way. If it is for white metal, lead, that is zinc, barbate, and alloys, that is the section lining that you should use. For magnesium, you use that one. We have rubber, plastic, electrical installations, we can use something like this. And then we have cross grain wood. This should be the section lining that should be used. Bedrock should be this one. Solid insulations, we have something like that. Marble, slate, glass, and porcelain and other things, we use something like that. Then we have liquids. This should be the lining used to be used. Electrical windings and cables, we use section linings like this. So in cases where you want to differentiate between the different type of material as you section through the object, then you can use the specific section lining that are relevant for that particular application. The spacing of the hatching lines is uniform to give good appearance to the drawing. Okay, you have to ensure that the spacings are uniform as possible. The pitch or distance between lines varies from 0.06 to 0.1 inch. You may convert that to millimeters depending on the size of the area to be sectioned. Section lining is similar in directions and spacing in all sections of a single component. Okay, so if you have a single component, all right, let's say that you have a single component, not an assemble. Even if it is assembled object, you've assembled have different type parts, and you've sectioned through. Let's say the cutting plane goes through more than one part, different parts, but the parts that are the same, that is, if you it goes through a particular part, you make sure that the sectioning of that part is the same. Okay, is constant for that particular part, that particular single part. It has to be constant, and directions should be similar. When you move to a different part in the same sectioning where a cutting plane have gone through more than one part, you ensure that the other part is also sectioned in a different orientation. Okay, the direction is different, so that you'll be able to differentiate between the two parts or the different parts of the object. Types of section views. There are different types of section views which we are going to look at. The first one is what we call full section. We have also half section. We have offset section. We have revolved section. We have removed sections. We have broken out sections. And we are going to look at these different types of sections one after the other. The first one is full section. Full section is when the cutting plane extends entirely through the object in a straight line and the front half of the object is theoretically removed. A full section is obtained. Okay, so when you have a cutting plane, let's take this figure for instance, and you have a cutting plane which have gone through this completely through the center, dividing it into two. Okay, this is what you call full section. So you have divided it completely into two. In 3D we have something like this. If you are to have the orthographic projection of it, we have something like that. So these are the views. So here, when not section, orthographic projection, let's say we have front view and then we have a side view of this object. When we have it in orthographic projection, you can see the hidden lines showing. Okay, so here for instance we have a hole through the center here which has been indicated with hidden lines here on this side view. The holes at the ends, this point and that point, we can also see them indicated with these short dashes here and then short dashes down there with the center lines showing. Now when we section through this, where we have the cutting plane going through the center, this form 3D, that's the cutting plane. Orthographic projection, we have represented the cutting plane with the line BB. So that's the line BB in the cutting plane line BB. We're observing in that direction, meaning that we are looking at whatever is remaining at this side of the cutting plane. And in that case, we are going to have the projection, the sectional view of it. And the sectional view is this one that we have here. And you realize that when we produce the sectional view, all the hidden lines that should show in the orthographic projection will disappear in this case. So for instance, if we look at the hole inside, which in orthographic projection we are having it as short dashes here, okay, on the sectional view it has been the short dashes is removed and we have continuous line. So this thick continuous line, the lines are showing the outline of that hole which passes through that portion of this object. Okay, so if you look at the holes at the ends too, we also have it there like that. This is what we call full section. The next one is half sections. A symmetrical object or assembly may be drawn as half section. Okay, if the object is symmetrical, we may draw half section. If you have just a portion of it removed, we know that whatever that we have revealed at that section will be the same as whatever is remaining at the other part. Okay, in that case, that's where we use the half section. And let's look at this one here. Okay, when we talk about half section, we should understand that it is not that the material have been cut into half. Okay, That wording maybe can be confusing because one thinks of showing half of the part. Remember, a half section shows 1/4 of the part and not one half. If we talk about one half of the part, we are talking about full section where the cutting plane have gone through completely, like the first one we looked at here. Okay, so in that case, we've divided it into two. We divided the object into two. So we are looking at the other half of it. This is, in this case, is full section, but um, in in this particular case, we may not necessarily say that we have divided the object into two because the object may not be symmetrical, but we still have full section because we have the cutting plane going through the object completely. But we'll talk about the um, half section. We are basically looking at removing uh, 1/4 of the object because the object is symmetrical. So if you look at this object here, when we cut along and as is through the center here, what we'll have now, we'll have the same thing above. And when we cut through vertically this direction, what we'll have at the left will be the same as what we are going to have at the right. So we may apply half section here, half section here. So let's look at this case. So here, half section, the cutting plane goes through just one portion, okay, halfway. It doesn't go through this completely. It goes halfway, then it deviates, and then it gets out of the part. And then let's look at the arrows. So you see that cutting plane A AA goes through the object and removes a portion of it. So here we are taking away this section, this portion here away, and viewing from this direction here. So when you view from this direction, you are going to observe and the features of this object, okay, from above up to that portion. You see that they will be revealed, and then the other portion will be there within the component. So over here, when you cut and remove this section and you view from this direction, this is what you are going to see. All right, so like we have here in 3D, we have gone through, cutting plane goes like that and comes this direction, and we remove this portion, this front section, we remove that from there, and we view from this direction. So view from this direction, this is what we are going to see, something like this. So here you'll see that this hole that we have inside here, a portion of it is revealed, and we are going to have this as a continuous line. This hole, we have it revealed, so we have continuous thick lines here. Then you realize that all the other features are gone, they are no more there. All right, we don't see them here, not because they are not there, because we are not seeing it because we are interested now on the sectioned area of the object. So where we have revealed, that is this continuous line, they have been revealed. The down one, which in number under number circumstance, number autographic projection, we should use short dashes to indicate. We don't do that. You just ensure that there are no more there. Okay, so when you are section, now your concentration is on the sectioned area of the object. So half section, this is how it's going to appear for this particular one. Let's go to the next one, offset section. In order to include features that are not in the straight line, the cutting plane line may be offset or bent so as to include several planes or curved surfaces. All right, so if you want to include several planes or curved surfaces, you may use the offset. Let's look at an example of that. If you take this one for instance, we see that this object is not symmetrical, okay, about both axes. If you cut through this direction or that direction, it's not symmetrical. Are you okay? Now there are several features on this object. We have this hole, that one, this one here, this one is there, the center portion is there, and you want to reveal these features. Okay, when you look at it, you realize that some of the holes are identical. Like if you look at the the top view here, you realize that this one here and that one here, they are identical. This and that are identical. Their relative positions are identical, okay, from the edges of the feature. So when you are sectioning this one, you may want to ensure that you are able to get through and reveal all the features of this object. And those ones which are identical, you may not have to reveal all of them. You just need to reveal only one, okay, so that it gives you an information of how those features will look like, even at the other ones. All right, so here in 3 dimension, you can see we have the cutting plane going through this one. We split through that one, and then we split through this one, and then we split through that. So we are offsetting from the plane, okay. So when you look at this cutting plane here, from here it goes through this object. There's an offset here, comes through this offset to the center of this feature here, goes through that. There's another offset here, then it goes through this one, and we are observing in this direction, looking the other direction, okay, upwards. So when you look at it from that direction, this will be your sectional view. This was offset section. So when you view from this direction, okay, from direction of the in the direction of the arrow, you are going to observe all the faces appearing in a plane like this. So we have the feature here, this one as this one here, this feature appearing as this, and then we also have the center feature here appearing as that. We have this one appearing as this. And you need to note that the offset area should not appear as a straight line on your section surface, okay. It should not appear there because it's not there in the first place. This is an imaginary plane going through the object so that we can reveal the features. So you do not have to draw any line here to indicate that offset, okay. It has to be it should not be there. All right, so it will appear as if it's continuous. So when you look at this one, it looks like something like a full section, but it's not full section, it's offset, because if you look at the cutting plane, it has offsetted through the various features. Then we have broken out section. We have broken out section. Broken out section when internal and external features of an object can be shown without drawing another view. Broken out and partial sections are used, okay. So where you want to, we can show them without drawing another view. We may use broken out section. A cutting plane line or a break line is used to indicate where the section is taken. The break line is normally a jagged line which better indicates the break. The broken out sections as a session save drawing time and drawing space. All right, so let's look at this one here. So here we don't want to draw another sectional view, okay. You're only interested in revealing a section or a portion, some small feature of this object. And let's say you have the orthographic projections of the object. Instead of you to have, let's say, a full section where you are going to provide full section for this one, and then in that full section all you are interested in is to reveal this feature here. You just do what you call the broken out section to reveal the feature. All right, so all the other portion of the orthographic projection will be there. Like for instance, if you look at this one, we are still seeing the short dashes here to indicate the hidden line of the hole that have gone through the object. If you look at the edges here, we are seeing them there, but we are interested in revealing this particular feature here. So we apply broken out section. So we have this jagged line here, okay, and then we reveal that portion of the object. Then we hatch the object where there is material. Where there is void, we leave it open. all the other portion of the object remains the same. We also have aligned section. Aligned section is not a true projection of the cut surface. It is often used when a part contains web, rib spokes, or similar features. It revolves or aligns special part features to clarify them or make them easier to represent in section. One can conceptually think about align section as a specialized offset sections. Let's look at this figure here. All right, so in this figure here we have a rounded object like a flange, okay, and this flange we have webs. These are webs here, and these are maybe some holes where we may want to bolt this flange together with a other component, and we're providing a section for this. So in this case it's like a full, we have a full section AA. I've gone through the center, okay, of this, so it has gone through this web here and that web through the center of it. In align section, we want to also reveal these features, this hole here, okay. We want to reveal them, and to reveal them, what you do is that you have to rotate the position of these holes so that they will be in line with the cutting plane so that you reveal them. In actual fact, it's not along a cutting plane, all right, but in order for you to be able to reveal them, you have to rotate them through that, and that is what we call the align section. So you align the object, the features you want to reveal here with the cutting plane and reveal them. So in this case, this is going to be your sectional drawing. So here we have the center, which is the void, the center hole going through is shown. The web, we don't section webs or rib. Okay, so these ribs here are left intact, we don't section them. Then we also have the hole which will appear. So we have revolved the hole to be in line with the cutting plane, and we reveal them over there, this point and that point, like that. The true projection of a section like this could be like this one here, but this is wrong. Okay, in drawing, this is how we do it. So all this slender or thin member like the web or the rib, we don't section them, and then we have to rotate these holes here to align with the cutting plane line. Then we derive them like this. Okay, so this is the correct one using the aligned section method. All right, this is another one here. Okay, so this is another one. In this case, this one is having 3 ribs, and the cutting plane have gone through like this. It goes through this one and then this side here. We want to reveal how this hole is, okay, and then we also want to ensure that this web is indicated. So we have to rotate this rib to align with the cutting plane, and then this hole to align with the cutting plane. Then we'll have the section like this. If you are using true projection, photographic projection, and you are viewing from along cutting plane BB, then this is how it will be like. But if we are doing sectioning properly, this is how it should be done, using the aligned section. All right, so we have another one here, also the same. Now let's go to revolve sections. A revolve section is made by revolving the cross-section view 90 degrees about an axis of revolution and superimposing the section view on the orthographic view. So let's look at this one here. Okay, this is one. Let's look at this one. So this is a shape, and this component here has different cross sections. Okay, so let's say we have the orthographic projection of a view like this. So in revolve section, we have opened or cut through this object. So the cutting plane is that's gone through this object at that section. The cross section that we see there, we revolve it through 90 degrees, okay, and draw it on the autograph projection part. So here we are going to say that the circular cross section of this object, when we cut through across it, is what we are having here. So revolve it through 90 degrees, and it's presented on the orthographic projection like that. Then we also have something like this. This section of it is having a cross section of an eye. Okay, so in this case, we open through, all right, cut through, the cutting plane has gone through, and then rotate the cross section through an angle of 90 and present it like that. This section too is the same thing. This is what we call revolve section. Then the next one, all right, so let's look at this one too. This is another example of revolve section. So here we have this 3D object and this cutting plane which have gone through and been observed in this direction, right? So we cut through the object, or cut through the object, determine the cross section, okay, at that area where the imaginary cutting plane is going through the object. Then you revolve it through an angle of 90. Okay, so we have the object presented on it. So if you are to draw the plan of this, it's something like this. The front view, okay, let's say the front view is like that. Then the revolve section is going to appear as this, and the cutting plane goes through this section of the object. Okay, and then this another one similar to that, but in this case we break, okay, broken view, where you try to separate the orthographic projection from the section itself, the cross section itself. So you have these jagged ends, and then you have your revolve section shown in this area here. Then we are going to look at removed section. A removed section differs from the revolve section in that the section is removed to an open area on the drawing instead of being drawn directly on the view. So this is the remove section. So in this case, it's something similar to revolve, but in this case, you are not drawing the object, okay, the section view on the orthographic projection, but you remove it and place it somewhere else. So let's say that we have a cutting plane AA going through this object, and we are viewing from this direction. When you view from this direction, the sectional view you are going to have is this outline that we are showing here. But instead of you to have it drawn on this drawing orthographic projection, you place it outside of it. Okay, so when you view from here, AA in this direction, the cross section there, you draw the cross section outside in this direction or anywhere on your paper. This is removed section because it's not placed on the object, it's taken out. Okay, and these are some parts that should not be sectioned. So let's look at them. We have some parts in drawing, you don't section them, or let me say you don't hatch them. Okay, so when you have section, even if the cutting plane have gone through them, you don't hatch them. These lines are not drawn, section lines are not drawn on these objects that we are coming to look at. The first one is spokes. Okay, spokes, we don't draw section lines on them. Gear teeth, we don't draw section lines on them. Shafts, bolts and nuts, pins, rivets, spindles, key studs, tin washers, all these we don't draw section lines on them. The objects above are more easily recognized by their external features, so they are not shown in section if cut longitudinally. Okay, so when you cut along the axis, you don't show, okay, you don't section them. However, section lines are drawn when the cutting plane cuts across the axis of the object. So when you have a cutting plane that goes across the object, the axis of the object, you have to draw section lines on them. But when it's along the axis, we don't draw because you can easily identify them by their external features. So let's look at examples of features that are not to be sectioned here. I've mentioned them here, but in a particular assembly, let's look at this assembly here where we can identify some of them, and you see that they are not sectioned. So if you look at this assembly, we have here a shaft. Okay, a shaft is here. Shaft have not been sectioned. Key have not been. Though we have a broken out section on the shaft, and the broken out section here is to reveal that key over there. Okay, so this is one application of the broken out section, but the shaft remains the same. Then we have a web. You see that the web here we've not sectioned. The key have not been sectioned. Then the rib. If you look at this rib here, assuming we have cut along the axis longitudinally, we will not section it, but because it's across it, we can see that it has been hatched or sectioned. Okay, we have the wheel. The wheel is here. Okay, the wheel we have cut across, we sectioned it. Spindle. Let's look at this spindle here, not sectioned. There's a nut here, not sectioned. This is a tin washer, not sectioned. Thick washer. If you look at the thick washer, we've cut across it, we have sectioned it. Okay, then we have here spokes. So this spoke here, no section for that. But in this case, where we want to, though here in this case we have the cutting plane going through the spoke, it's not section, we've left it, it's longitudinal. But when we want to present a cross section of it, okay, in that case we cut across the axis, we have to do over here revolve section. So that is where we are having here this is a revolve section for the spokes. All right, so let's also look at this one here. So this is another one. In this case we have this object. Okay, we have this object here, and there are various features. We have screw here which have not been sectioned. We have key, the key have not been sectioned. This is a shaft. Okay, and we have some revolve section done here. There's a pin. Okay, we've done broken out section to reveal the shaft, and then we also have a pin here which has not been sectioned. You see, then we have a revolve section in this section here. We have a rib. This rib here is left like that. Okay, this is a rivet is left like that. There's a rib here, no hatching of it. A stud here, no hatching of the stud. There's a nut, no hatching of the nut. And here we have break. Okay, here we call it the round section, where you have broken some portion of a shaft. We provide this section to indicate that this is not the complete shaft. Okay, a portion have been removed from there. Okay, now we're going to look at some sample or some examples. So it says that the components shown in figure 2.18 are drawn in first angle or third angle projections. Sketch the sectional view of each component. Okay, so we have these components drawn, and we have to sketch the sectional views of each component of this drawing. So here we have this one is drawn in either, it says these are drawn in either first or third angle projection. So we have to identify which angle projection we have here. In this case, we have a plan here. There is two views above, so we know that this could be front view and this could be end view. If this is plan, then this we can say it is first angle projection. Similar to this one here too. We have three views, two above, one below. This is the plan. This is front view, this end view. First angle projection. Okay. If you look at this one here, we have a plan above, two views below. So plan up, front view down, end view. This is third angle projection. If you look at item 4, we have two views below, one above. This we can say is third angle projection. If you come to this one too, this we can say is first angle, and this one we can say is third angle. That's number 6. Okay, so let's look at them one by one. So the first one we have item 1. This is the cutting plane. This is the cutting plane here. Let's say cutting plane AA. All right, and it's pointing upwards. So basically what we are going to do, we are to draw the sectional front view of this particular arrangement that we have here, because you're observing in this direction. If you observe in the direction of the arrow given, then it means that it is the front view that should come. So sectional front view. Here the front view have been drawn already, and we can see the features shown. Okay, we have hidden lines shown here, short dashes indicating that there are some features of this which cannot be seen from the direction when you view and project the front view. So when you look at the cutting plane and look at the position of the cutting plane, it has gone through this object, through the center. So here you'll see that on the front view, there's some short dashes here which will indicate, or which indicate the slot that we have inside here. There are some short dashes here, okay, with a center line. It tells us that there is a hole going through that section. We can also visualize that on the plan. So on the plan, we also have some short dashes here, representing the same hole. On the front view, which confirms that, you can see this circle here, telling us that there is a hole in that section. It's having center lines there. And the slot in front here have been shown on the front view, the end view, as this area here. Okay, so now let's look at the cutting. The cutting plane have gone through all these features. It has gone through the slot in front, it has gone through the hole. So it has to reveal the features of the hole. And that means that this line here, which is appearing as short dashes, will now be a continuous line. This one here will be a continuous line, and that will be a continuous line. Okay, so now let's go and look at it. Let's see how we can section these things here. Okay, so this is what we have. Now let's observe them. So we have this, and we are to provide the sectional view for this. The cutting plane have been given to us. The cutting plane is here. So we have cutting plane arrow to arrow. Let's say that cutting plane AA. Okay, cutting plane AA, and we are observing in that direction. So basically, in this case, we are just going to draw the sectional front view in this case. So you see that when you look at the cutting plane, it has gone through the feature here, this slot here. It has gone through the hole at the back. So this hole in the feature, the slot in front here, they will not have, there's no material there, it's void inside. Okay, so we have to ensure that we reveal those features. So we know that here this short dash is now going to be a continuous line. Okay, to be a continuous line now. So it will no more be short dashes. Then this one too here will be continuous, and that will be continuous. So you have continuous line here, continuous line. Okay, the center line will have to be there, so we have the center line inside there. Now we need to isolate some areas. So areas where there are no material, where the cutting plane doesn't go through any material, we need to isolate those places and leave it out, okay? So that we not hatch those areas. So over here, in front here, there is a slot. So here, there is a slot here. It's void. So we don't hatch. We don't provide section lining in this area. Okay, so we have to ensure that this area is out. Where the hole is, okay, where the hole is, it's also void. There's no material there. So we don't section there. So the area now where we are going to hatch, okay, where we're going to have the section lining, it's not going to be these areas here. Okay, so where we're going to have the section lining should be these areas. We say that this section lining should be inclined at an angle of 45. Okay, 45. So this will be the need to provide the hatch lines here and ensure that the spacing are as uniform as possible, and the angle is 45 degrees. Okay, 45 degrees, like that. So basically those are the areas we are going to section. So if you are to draw a sectional front view for this, what you are going to draw is to draw this front view, okay? Then ensure that those hidden lines are revealed, because the cutting plane is going through them. In cases where you may have some hidden objects somewhere where the cutting plane doesn't go through, you don't show it at all. You don't show it with short dashes. You don't show it with any continuous line, because basically you are not interested in that area. That's why we are providing that section for the areas you are specifically interested in. So this one here is a full section. Okay. Now let's look at another one. Let's look at another one. So let's look at number 2. Number 2, we have also an object drawn in first angle projection, and we are to provide a sectioning. We are to provide sectioning for it. Okay, so in this case, let's look at the cutting plane. Cutting plane, let's call this one cutting plane BB. Okay, cutting plane BB. So cutting plane BB, we're observing. Look at the direction of the arrow, in this direction. So basically, we are to draw the sectional front view, because when you look at it from this direction, this is the end view, the direction. If you look at it from here, you are going to observe the front view. That will be the projection that you would have. Okay. Now let's analyze it. So we need to be able to get true picture of how this object look like and the position of the cutting plane. Then we can produce the sectional view of it. So if you look at it here on the plan, see at the back there's something like a slot there. We can see a slot there at the back. Okay, it's void, it's open. Then we see some short dashes in front. I mean at the bottom. Okay, on the plan we can see these short dashes. If you look at the end view, we have this slot here. Then we have these short dashes here. Okay, if you look at the front view, we have these short dashes here. What it's telling us is that this object here have some void from the back, and then at the bottom is void. There's a hole, I mean that space through the back and the bottom. Then there is a web here. We can see a web on the front view. Let's say this tipped inclined surface. Okay, this indicates a web. We can have a representation of it on the plan, which is made up of these two lines here. That's the web. And on the end view, we can also have the web represented in this direction. We know that webs we don't section webs. Okay, so here if we are to provide a sectional front view, again, if you look at the cutting plane, it has gone through the center of this member, so it will reveal all the hidden features. So on the front view, this line which is appearing as short dashes will have to become continuous. So this one here will be a continuous line. So this one here will be continuous instead of it being it will be continuous. Okay, so you have it being continuous. Then you also have this vertical line as continuous. So this vertical line will also be a continuous line, so it will not be hidden again. So that's the front view. We are looking at the front view. Okay, so we'll have this one to be continuous, and then this one to be continuous, because it will be revealed by the cutting plane. Now we need to isolate the areas we will not hatch. We know that from the back through the bottom there is void. Okay, so in that case we are going to ensure that we isolate the void. So here there is void throughout. Okay, so here we don't hatch it, so it should be plain. All right, then this is a web, the web 2, we don't hatch the web. Okay, so the web 2 is isolated. We don't hatch the web, we don't hatch the void around the object from the back and the bottom. So the only place that will be left for us to hatch will be this area here, where there is material the object have cut through. Again, we use the inclined line. The hatch lines should be inclined at an angle of 45, and ensure that you have spacing that are as equal as possible. Okay, all right, so here we will not hatch, and here we will not hatch this area, okay, at all, but you only hatch the area where we have material. The web, we don't hatch the web or rib. Let's note that. All right, let's go to the next one. Let's go to the next one. So let's look at these ones here. Okay, so here we are looking at this item 3. So this is third angle projection. We have two views down and then one up. This is the plan. Let's take this as the plan. And then we have this as the front view. And we have the end view over here. Okay, so in this case, we have the cutting plane on the end view. And that's the direction, third angle projection. So which view are we going to have? That would be sectional front view. Okay, so sectional front view, basically we are going to draw the front view, then we hatch it, we section it. All right, so we provide a sectional front view for this one. All right, so to do that we have to sketch. Okay, so here let's say that we have the cutting plane going through as we have been shown. If you look at the features clearly, you realize that the cutting plane have gone through the center of this member, and it has revealed, it has gone through all the hidden features of the member. So when it's gone through, you have all the hidden features to be revealed in this particular case. So let's look at the hole here. We have this hole here Okay, we have this one too here. All right, then there is that one at the bottom area. Okay, that we can have them represented too on the end view. We can see them clearly there, those hidden features. When you come to the plan, it has been revealed there. You see that this hole at the end here will appear at this hole here, this circle there. Okay, then you will have also this one here. Okay, this hole inside is the inner circle. Then the slot that we are having down here on the plan, we can see it showing like this. So that's the view on the plan, and the cutting plane have gone through. So if you look at the end view, it has gone through all those features, and those features have been represented here. Okay, so what will happen is that now all those features which have been represented here, these hidden short dashes, we need to ensure that they appear, they are revealed. So what you do is to ensure that instead of this one being hidden lines, it will now be continuous. Okay, so you have this being continuous, this line here, and that one will be continuous. So basically you draw the same thing, but this time you review the features, those hidden features will be revealed. So now instead of short dashes, you have thick continuous line. So you have thick continuous line here too. Then this one will be continuous. Okay, you have this as continuous, you have this as continuous, like that. Then when you are done, you need to isolate the places that you will not hatch. Okay, so there are some places we don't hatch. Those places let's determine them. This is a web. We can identify that this is a web. We don't hatch this one. It's a web. Okay, so this one here will not hatch it. It's a web. Then we also have this area here. These are void. They are holes through the object. It's hole through it. We will not hatch it. This area here is a void. We will not hatch this area. Okay. Then when we have cut through the object, you realize that this line here will disappear. Okay, this line from here up to this point, basically it will not be there. Okay, those lines will not be there. All right, so what you do is to ensure that as you are drawing, you draw it in such a way that those lines there do not come. So you don't have these lines there. It should not come. Okay, because now when the cutting plane goes through the material, that area here, basically that line will be showing the edges at the end here. Okay, these edges here, or that edges over there. So they will not appear when the cutting plane goes through. It will reveal the inner area of the material. Okay, so those areas, those lines will not appear. Then the area we are going to hatch will be this area here. Okay, where there is some material that the cutting plane have gone through. All right, so you have 8 hatched this way. All right, so this will be the sectional front view for this particular one.
This will be the sectional front view for this one. So what we are going to do now is to ensure that we have done up to 3. So as you come to class, make sure that you do from 4 to 6, okay? Do from item number 4 to number 6. So when you finish number 4 to 6, do it, just sketch there. So number 4, we have it drawn in third angle projection, and we have the cutting plane on the front view. So we have to draw sectional end view. So here you'll have to section the end view, okay, provide the hatching, and then number 5, we have the cutting plane on the front view, and in this case we have to draw the sectional end view as well. This in first angle projection. So sectional end view, basically we are going to draw the end view, and then you hatch where you are supposed to hatch and where you are not supposed to, and reveal the features you have to reveal. Then we also draw the item 6. The 6 here, we are dealing with the this in third angle projection. The cutting plane is on the front view, so we are going to draw sectional end view. So we are looking at it from this direction. This is what you will draw. Then you hatch areas you are supposed to hatch, where you are not supposed to. The lines that should appear, those lines which are not supposed to appear, you do that, okay? So you draw the sectional end view. Then when that is done, we'll continue with the other ones, okay? So we'll look at some example here, like this one, where you have to draw the sectional view of this bracket and using cutting plane XX. So divide. So in this case, in 3D, you have to produce the projection of this, the sectional drawing of that in the direction of the arrow. Then we also have this one here in the direction of arrow XX. Draw a sectional view of this block. We'll also look at that one. All right, thank you very much, and have a nice time.